Okay, so we're going to talk about question number 1. Now, here's a couple of things, and this is going to talk about how things in algebra, everything builds on what we've learned previously. This equation is in slope-intercept form, y equals mx plus b. Your y-intercept is that value that is not next to the x. So 4 is our y-intercept. That I should have put b, not 4, and to put b. Dang it. There we go. So that means we want to have it on this y-axis. That's your y-axis. Okay? I'm going to count, start from the origin. I'm going to go up 1, 2, 3, 4, and I'm going to put my dot. That's my beginning dot. That's your beginning value. Your slope is in front of the x. That's your rise over your run. Your rise is the number on top, which is 2. The run is the number on the bottom, which is 5. It's negative 2, so that means we want to go down 2, run 5. You always run forward unless you're going backwards. So from our beginning value, that means we're getting smaller. I'm going down 1, 2, and then I'm going to run forward 5 units. I'm going to go opposite day now to get one more point. I'm going to go up 2 and then back 5. 1, 2, 3, 4. Oops. That's a 6, not a 5. That number right there looks like a 6, or looks like a 5. I'm going to take my ruler. Now, my line, look at our inequality symbol. It should be dotted because there's no line underneath. So whenever there's a no line underneath, we know that this is open. Our inequality is going to the left. That means less than. That means below. We're going to shade below, and our line is dotted. So we are going to shade on this side. If you don't have a highlighter, you can just draw lines going right down like so. Does that make sense? That can also save you a little bit of time if you don't want to be like extra. Now, if you want to be like artistic, sure. Now, it asks if the point 0, 0, that's the point right there. Is it a solution? That point 0, 0 is in the shaded area. So it should be yes. Now, I'm going to talk to you about using it as a test point. Test point, we're going to plug it in. So y equals 0, so 0 less than negative 2/5 times x is 0 plus 4. We're evaluating that point. That's going to give me 0. 0 times 2/5 is 0. So the only thing we have left on that side is 4, because that 2/5 is gone. Is 0 less than 4? Yes, this is true. So that means that it should be in the shaded region. If it came back false, then we know we shaded the wrong side. Any questions? How do we feel about this? Pretty easy, right? Okay, we're going to go to number 2, which is below. Again, I want you to look. This is y equals mx plus b. There is an x value, so this is not Hoy. Your b is invisible. Anytime your b is invisible, your y-intercept is 0. So I'm going to put a dot at 0. Your slope is next to the x. So our slope is 3, and that's 3 over 1 because 1 is always there. I'm going to go up 3. 1, 2, 3, and then right 1. I'm going to go ahead and do more dots. Typically, to clarify with especially linear inequalities, you want to do as many points as you can, especially if it's open, so that you can make sure to get the right points, because you'll be asked on tests. You'll be given a list of points and you'll be asked to select the points that are true or not true, right? So you want to make sure that you are more precise on graphing your point. Now, if you're on the computer, you can pretty easily just do 2 points and graph it and then shade the right side. But right now, since we're on paper, we want to be more precise. And again, our line here, so this is a dotted line because it's open. And we're going to the right. So that means we're going to shade above. That means name, the side that has our name. So if I do my line, this is definitely one of those lines that can get a little tricky on shading above and below. Look, if I write my name, don't write your name here. If I write my name right here like this, that's incorrect way to write our name, right? We want to write our name on the line. So Epps is going to be on the line on top. Okay? That means above. We're writing our name above. Since we want to shade above, we want to have the side that has our name. So this is the side that we're going to shade. Oh, look, I got Christmas colors. I should have used other colors because it's not Christmas yet. Now, here's a tricky question. 0, 0. Remember, in the case of this equation, that is our y-intercept in this equation. That means it's on the boundary line. Since this is an open boundary line, then it is not a solution. Now, if you think about it in testing, that would be 0 greater than 3 times 0. That would be 0 greater than 0. That is false. So if your test gives you a false result, then it is not a solution because 0 is equal to 0. If it was y greater than or equal to 3x, then yes, then it would be a solution. Okay? All right, we're going to go above. Number 3. Let's see, let's use Christmas or Halloween colors. So we got y equals mx plus b. Notice I do not have an x. That means our slope, our x, is 0. That means that we have a y-intercept at 4. Remember, this should remind you if there's no x, that's Hoy. There's a line underneath, so we don't want a dotted line. We want a solid line. So we want solid line because we're closed. And we are going to shade above. So I'm going to write my name on the line. So that means I want to shade the side that has my name. Oh, I should have, hold on. Let's see. Let's do purple. Is 0, 0, that's the point 0, 0. It's in the non-shade region, so it is not a solution. And then number 4. Okay, so this is in standard form. Right? All the other ones were in slope-intercept form. Okay? Now, we're going to do our x-intercept and our y-intercept. Your x-intercept is, or your y-intercept is when x is equal to 0. Your y-intercept or your x-intercept is when x is equal to 0. If x is equal to 0, you get negative 2y greater than 12. 12 divided by negative 2 would give you negative 6. If y is equal to 0, you cover up the 2y. That gives you 3x greater than 12, which would give you x is equal to 4. So we're going to plot those 2 points. So we got 0, negative 6, and 4, 0. And our line is dotted. And we're going to talk about above or below in just a moment, because this is definitely a special case. I need y'all listening. Anytime you are identifying above or below, it needs to be in slope-intercept form. You need to think we're asking, is y less than that rule, or is y greater than that rule? Does everybody make sense? Now, with inequalities, remember, when you divide or multiply by a negative number, what happens to the inequality? It flips, changes direction. You can take the time and put this in slope-intercept form, but we already have it graphed. So there are 2 ways that we can go about this. One way is we can do our test point. So we can plug in 0, 0, especially with it being in standard form. So if I plug in 3 times 0 minus 2 times 0 greater than 12. 3 times 0 is 0. Negative 2 times 0 is 0. So that gives me 0 on that side greater than 12. Is 0 greater than 12? No, it's false. Okay? That means the point 0, 0 needs to be not shaded. So here's my name. So in other words, if I shade above, because right now this is saying to shade above, right? Because it's going to the right. To the right means to shade above. But when I test this rule, 0 is not greater than 12. So that means I need to shade below, so the side that does not have my name. Now, I want to tell you why that is the case in this situation. Remember, if I were to divide by negative 2 to put this in slope-intercept form, then my inequality would flip in the other direction. So look, so this would be negative 2y greater than negative 3x plus 12. Divide everything by negative 2, the coefficient with y. So y is less than 3 halves x minus 6. So now this is saying below. Anytime there is a negative coefficient with the y, remember you're going to flip the inequality symbol. Does that make sense? Now, if you can't remember that, put it in slope-intercept form. Okay? Any questions? All right, you have a practice sheet. Go ahead and get started on those first 6 questions. I'm going to set this up so that we can do the bottom